Welcome back to the Linear Algebra series. In today's video, I'm going to be discussing linear combinations. This is a really essential topic in linear algebra because it involves combining constants and vectors, which is a really integral part of this course. So now let's look at what a linear combination is. So it refers to an expression constructed from a set of terms by multiplying each term by a constant and adding the results. So let me explain what the general form is. Let me explain the general form of a linear combination. So we have vectors v1, v2, all the way until vn, and coefficients c1, c2, all the way until cn. So the general form is w is equal to c1 v1 plus c2 v2 all the way until Cn Vn. So this is the general form of linear combinations. Now let's look at examples to help understand this concept better. So we have two vectors, vector A and vector B. So we have to find a vector W, which is a linear combination of A and B with coefficients 2 and -1 respectively. So we know our coefficients C1 and C2. We know these values. These are 2 and -1. So we can write this as W is equal to C1 V1 plus C2 V2, as we have only two coefficients and only two vectors. C1 is 2 and V1 is A. So A, I'm just going to write it as A, plus C2 is -1 and V2 is B. Now let's substitute the given vectors. So W would be equal to 2 times A, which is 2 times 1, 2, plus -1 times vector b, which is 3, 4. Now let's perform the scalar multiplication and addition to find out what w is. So we multiply this 2 by the 1 and the 2. So we get 2 times 1, which is 2, and 2 times 2, which is 4, plus -1 times 3, which is -3, and -1 times 4, which is -4. Now we just add these two vectors. We get 2 plus -3, which is just 2 minus 3. So 2 minus 3, and the bottom part is 4 minus 4. This gives W as -1 and 0. So the linear combination W is equal to -1 and 0. That's how easy it is. It really is that simple. But the only thing with this topic is there are several different ways they can ask this question. This was one way. Now let's look at another way in which we can do this. So this is our next question. Express the vector v, so this is our vector, as a linear combination of u1 and u2. So u1 and u2 are also vectors. So we need to find the scalars a and b such that v is equal to a times u1 plus b times u2. So a is essentially c1, this is v1, this is c2, and this is v2, and this is our w. So I'm just explaining how this compares to our original general form of linear combinations. So now let's substitute our given vectors. We know the value of v, which is 7, 10. A, we don't know what a is. u1 is just 1, 1, plus b, which we have to find, and then u2 is 2 and 3. So now all we have to do is perform and perform several functions such that we can simplify the right-hand side. So this would become a and a because a times 1 is a, and then a times 1 again is a. And this would be b times 2, which is 2b, and b times 3, which is 3b. So we get 7, 10 is equal to a plus 2b and a plus 3b. So now we have a system of equations, and we can easily solve this by just forming two equations. We can write this as an augmented matrix, or we can just do it like this. So if you want to know more about augmented matrices, I have made a video in the past, and make sure you go check that out if you want to learn how to do those. So we can just solve this out. If we solve this out, we get a plus 2b. We can just subtract the two equations. So a plus 3b minus a plus 2b is equal to 10 minus 7. So I'm just subtracting the two equations because the a's will get cancelled. So you'd get a plus 3b minus a minus 2b is equal to 3. The a's cancel out. 3b minus 2b is just b, so b is equal to 3. Now let's plug in b equals 3 into this equation. So you get a plus 2 times 3 is equal to 7. So a plus 6 is equal to 7, and a is equal to 1. So we got our values of a and b. Now our last step is to just write it out. So v is 1 times u1 plus 3 times u2. Therefore, v, which is 7 over 10, is equal to 1 times 1, 1 plus 3 times 2, 3. This is how we write out our final answer. So that's how easy vector combinations is. So this one was when we needed to find a and b, and we had to express the vectors as a linear combination. So let's do a quick summary of what we did today. We learned that linear combinations refers to an expression constructed from a set of terms where you multiply each term by a constant and add the results. We also looked at the general form, which is W is equal to C1 V1 plus C2 V2 and so on until Cn Vn. And then we looked at two example problems. One where it was about linear combinations of vectors where we had to find W, and in the second example, we had W, but we had to find C1 and C2. We had to find these two in the second example. So thank you, and that's it for today's video. In today's video, I discussed the really important topic of linear combinations. I hope you all like and subscribe, and please make sure you turn on the bell icon so that you'll be notified for when I upload my next video. Thank you.